Hi everyone. So in the previous sessions, I have discussed about different types of AC circuits. Okay, so like AC through pure resistive circuit, AC through pure inductive circuit, capacitive circuit, AC through series of RC circuit, RL circuit and RLC circuit. Okay, so we have discussed different types of AC circuits. So in this session, we shall move on to the problems which are related to these circuits. So in the first problem you can see, so applied voltage is provided in the problem, which is V is equal to 400 sin 418t, and I also given, that is instantaneous current is also provided in the problem. So 2.4 sin 418 minus 1.37. So these two equations are given in the problem. Now, so based on these two equations, so we need to calculate the value of frequency, that is F. So next, phase angle. So phase angle means the phase difference between the voltage and the current. So next, the resistance of a circuit. So we need to find out the frequency and the phase difference between the voltage and the current, and the last one is resistance of a circuit. So here, from these two equations, so we can calculate the value of Vm and Im. Because if you just compare this equation with the standard equation, so we know that V is equal to Vm sin omega t. So here we need to identify which is Vm. Vm is equal to 400 because 400 is the maximum voltage. And what is Im? Im is equal to 2.4. So, and the unit of this voltage is volts and unit of current is amperes. After considering this Vm and Im, like two maximum values, so we can calculate the first value, which is the frequency. So we know that omega is equal to 2 pi f. Okay, we can have this equation to calculate the value of frequency. And what is omega? So here omega is 418t. 418. So now what is omega? Omega is equal to 418, which is equal to 2 pi f. So we can calculate the value of f. We can calculate the value of f as 418 divided by 2 pi. I think already we have calculated frequency in the previous problems. In this way we can calculate the value of frequency. And the next one is, so phase difference between voltage and current. So you can just look into these two equations. So what you can understand from here, so I is equal to 2.4 sin 418t minus 1.37. So that means there is a lag in current. But how much of lag? So that we need to we can calculate using this 1.37. So now the given value is in terms of radian. So we need to convert this value into degree. So how we can calculate this into degree? So 1.37 into 180 divided by pi. So remember, whenever we are calculating from degree to radians, so we need to multiply by pi by 180. So whenever we want to calculate from radians to degree, so we need to multiply. We need to multiply by 180 by pi. Okay. So after converting this to, after simplifying this equation, you get in terms of degree. So we have obtained frequency as 66.5 Hertz, and we have obtained the angle, which is 78.5 degree. So what we can say? We can say what is the phase difference between the voltage and current? It is of 78.5 degree. So now the last part is resistance. How we can calculate the value of resistance or resistance of the circuit? So to calculate the resistance of the circuit, so that means that is at the third part. So remember, the first one is frequency, and the second part is the angle difference, and the third part is resistance. So remember, we have an equation called cos phi, which is equal to R divided by Z. and we also call this cos phi as power factor. So remember, there is an equation called cos phi, which is a power factor. Cos phi is equal to R divided by Z, and using this equation we can calculate the value of R. But to calculate the value of R, so here we must be knowing the value of phi as well as Z. So of course we know the value of phi, which is 78.5 degree, and so what is the value of Z? So Z can also be calculated with the help of Vrms divided by Irms. Okay, impedance can be calculated in this form, which is Vrms divided by Irms. So what is Vrms? Vrms is equal to Vm by root 2. So divided by Irms is equal to Im by root 2, and we get 166.6 ohm as impedance. And once we calculate the value of impedance, later on you can substitute here to calculate the value of R, because R is equal to Z into cos phi. So substitute the value of Z here. R is equal to 166.6 cos of, and so we know the angle difference, which is 78.5, and after simplifying this equation we get 33.22 ohms. So finally we have calculated the frequency and the angle difference. Next is resistance of the circuit. So now we shall move on to the next problem, and in the next problem, so these are the values provided, and the applied voltage V is equal to, so 141 sin 3140 plus pi by 3. So here this voltage is applied to an individual circuit. So remember, this voltage is applied to an individual circuit. So in the first circuit consists of resistor of 20 ohm, and in the second circuit inductance of 0.1 Henry, and in the third circuit, so capacitance of 100 microfarad. Okay, so in each case, that means from each circuit, so you need to calculate the value of, that is RMS value of current. So we need to calculate the RMS value of current, that is in each case. Next, power dissipated in a circuit, and so we need to write the phasor diagram. So we need to draw a phasor diagram, right? So now based on the equations, based on the values provided, so we need to calculate these three in individual cases or in each cases. Okay, so in the first equation you can see applied voltage is given, and from the applied voltage, so what values you can extract? So you know that V is equal to, so the standard equation is Vm sin omega t plus phi. Okay, so we have some angle, and so what is Vm here? If you just compare the first equation with the standard equation, Vm is equal to, so 141, and what is omega? Omega is equal to, so you know that omega is 2 pi f, and where omega is 314, which is equal to 2 pi f, and f is equal to 50 hertz, right? And so here the angle pi by 3. So what is angle pi by 3? What is angle pi by 3? Which is equal to, so now I want this angle in terms of degree. So I have to multiply this with 180 divided by pi. So you get finally 60 degree. Okay, from the given equation, so we have calculated or we have identified these values. One is Vm frequency and the angle, which is 60 degree. So in the first case we need to calculate. So in the first case means, that is the circuit consisting of only resistor of 20 ohm. So let us take the first circuit, and which consists of only resistor. So that means R value is given here. So we need to calculate the value of what? RMS value of current. So what is the equation in a pure resistive circuit? So RMS value I is equal to which is Vrms divided by R. So remember, this IRMS is equal to VRMS divided by R. So here instead of Z we are taking R. Why? Because it consists of only resistor, that is R. So IRMS can be calculated as what is VRMS. So here how we can calculate VRMS, which is VM divided by root 2, and so divided by R. R is equal to 20 ohm. So you can simplify this equation, then you get IRMS as, so we get 4.985 amperes. Okay, so next one is power dissipated in a circuit, power dissipated in a pure resistor circuit, and we know that P is equal to V into I. So where V is nothing but again VRMS, so that we obtained from this Vm by root 2. So Vm by root 2 into I, which is 4.9, and we get the value as 497.02 watts. Right, so we have calculated the RMS value of current, then the power dissipated in a circuit. And so next one is the phasor diagram. So how we can draw a phasor diagram, and since there is no phase difference, between the voltage and current in a pure resistive circuit, so if I consider I as a reference and VR also exists in the same line. So remember, since there is no phase difference between the voltage and current in a pure resistance circuit, so we get, or we can have the phasor diagram in this form. And using the second part, that is in a pure inductance of 0.1 Henry. So in a second part, L is given as 0.1 Henry. So what we need to calculate? We need to calculate the first value, that is IRMS. So what is IRMS? IRMS is equal to VRMS divided by XL. So remember, IRMS is equal to VRMS divided by XL. It is not L. So we need to have in terms of XL. So how we can calculate XL? XL is equal to 2 pi F into L. So substitute the value of L, you can calculate the value of XL, and later you can substitute here. So later you can substitute here to calculate the value of IRMS. And in the second part, so what is the power dissipated in a pure inductive circuit? As we have already discussed, as I have already explained you in a pure capacitance circuit and pure inductance circuit, so there is no power. Okay, since it does not consume any power, so straight away you can take P is equal to 0. So power is equal to 0 because there is no power dissipation in a pure inductive and capacitance circuit. So, and in the third case, that is in phasor diagram. So in the phasor diagram, so you are already aware that, so there will be a 90-degree phase difference between the applied voltage and the current. Okay, current which passes through inductance. So here remember, I am just recalling again. So there is a 90-degree phase difference between the current and the voltage, that is applied voltage. But here, so even though it is 90 degrees, and we have also discussed the different cases, whether it is phase lag or phase lead. And remember, in a pure inductance circuit, always the current lags voltage by 90 degrees. I am just repeating the sentence. So in a pure inductance circuit, current I, okay, so lags voltage by 90 degree. And so based on the equation provided, so we need to have, so for example, if this is the reference, so I am not going to name this reference point, and from the reference point, so here we know that voltage is leading, which is of pi by 3. So what is pi by 3? Pi by 3 is 60 degree. Okay, so let me call this as voltage, which is the applied voltage. And so now we need to have the current. So where should I get the current here? Because you know that there is a 90 degree phase. There is a 90 degree phase difference between the voltage and current. So here at this point, that is So now we know that from this point to this point, that means angle difference between V and I is 90 degree. Okay, the angle difference between the voltage and the current is 90 degree, so minus 60 degree. So what is this minus 60 degree? Because from the reference point there is a lead of voltage, okay, by 60 degree. So 90 minus 60 degree, so here we get 30 degree. So now the angle difference between, that is from the reference point to this I, is 30 degree. Okay, so totally here we have 90 degree, because 60 plus 30 is 90 degree. So this is how we can draw a phasor diagram for pure inductive circuit. So that is pure inductive circuit. See here, now the current lags voltage by 90 degree. Okay, so it is applied voltage and this is the current which passes through inductance. So similarly in the third case is the circuit, AC circuit, which is having only capacitance, that is capacitance of 100 microfarad. So 100 microfarad, so C is equal to 100 microfarad. Okay, so and from this capacitance we can calculate the value of Xc. So what is Xc? Xc is equal to 1 by 2 pi f into C. We know the value of frequency, so you can substitute the value of frequency and the capacitance, so we can calculate the value of Xc. And once we calculate the value of Xc, so we need to have the first value, or we need to calculate the first value, which is RMS value of current. So what is RMS value of current? Again, IRMS is equal to VRMS divided by Xc. So Xc can be calculated using this equation, and VRMS is nothing but Vm by root 2. So you can simplify this equation, then you will get IRMS. And in the second part again the power, okay, power dissipated, as I have already explained you. So there is no power in a pure inductive circuit and capacitance circuit, so straight away you can write. But so when you write this P is equal to 0, so you can just mention the reason. Since it does not consume any power, so we are writing P is equal to 0. And in the third case, so we need to draw a phasor diagram for pure capacitive circuit. And as I have already told you, so 1 must be the reference one, and from this point, so we are having voltage which is of 60 degree difference, because the voltage is leading from the reference point. Now the question is, so where should I draw the current? So, and we know that in a pure capacitive circuit, always the current leads voltage by 90 degree. So remember, in a capacitance circuit, so current leads voltage by 90 degree. So that means we have, so already we have this 60 degree, and from the voltage point I should write the current, and which is of 90 degree difference. So plus 90 here from the reference point, so we get 150 degree. Then where should we get the current here? So again, the difference between voltage and the current must be 90 degree. So now the total angle from the reference point is, from the reference point is 150 degree, because 90 plus 60. Okay, I hope it is clear. So since the current leads voltage by 90 degree, so total angle we are getting it as 150, which we have obtained from, so that is 90 plus 60. So this is how we write, or this is how we draw the phasor diagram for pure capacitive circuit. So now in the next problem, so you can just read this problem. An inductive coil draws a current of, now so we have a circuit which consists of inductive coil. So remember, coil is nothing but the combination of resistance and the inductance. So coil does not consist of only inductance. So remember, coil coil means it does not consist of only inductance, it consists of two elements, one is resistance and another one is inductance. The combination of R and L, we call it as a coil, okay, and which draws a current of 2 amperes. So that means the current which is passing through resistance and inductance, that is 2 amperes. And when connected to a 230 volts, so now the circuit is, or these two elements are connected in series, so connected to a 230 volts across 230 volts and 50 hertz. 50 hertz is the frequency. So now the circuit is provided in this form. So now we have a coil which is the combination of R and L. Remember, this is nothing but a coil, and so which draws a current of 2 amperes and which is connected across 230 volts and 50 hertz. Our power taken by the coil is 100 watts. So now we need to calculate the value of resistance and inductance. That means we need to calculate the value of R and L. Okay. So, and initially to find the value of resistor, so we know that the power taken by the coil P is given, and we can have the equation P is equal to I square into R. Okay, power taken by the coil. So we can have only resistance because inductance does not come into the picture because it never consumes any power. So we can have this equation P is given, which is 100 watts, is equal to, what is I? I is equal to 2 amperes, so it is 2 square into R. So we can calculate the value of this R, right, and which is of 25 ohm. And once we calculate the value of resistance, so we need to calculate the value of inductance. And to calculate the value of inductance, so we need to calculate the value of Z, impedance. Z is equal to, we know that V divided by I. So this capital V and capital I means what? Vrms and Irms. So what is Vrms? The value which is provided, that is 230 volt is nothing but Vrms. So directly they have provided the value of Vrms. Okay, so we can substitute the value of V, which is 230 volts, divided by I is equal to, which is 2. So we can calculate the value of Z. And once we calculate the value of Z, so later we can think of calculating L. So how? That is, we know that Z is equal to R plus J into XL. Okay, so Z is equal to R plus J into X. So what is Z? Which is 115 ohm. So we can have this value 115 ohm is equal to, what is R? R is equal to 25 plus J into XL. So now it is in complex form. So we can calculate, we can have it in terms of magnitude. So you know the equation Z is equal to, so square root of R square plus XL square. So we can have this equation to calculate the value of XL. So now substitute the value of Z, which is 115 is equal to square root of, so 25 square plus XL square. Right. So from this equation we can calculate the value of XL, where XL is equal to 112.25. So what is a unit? Unit is again ohm. So now I have calculated the value of XL, and of course once we calculate the value of XL, we can easily calculate the value of L, because we know that XL is equal to 2 pi f into L. So where L is equal to XL divided by 2 pi f. So we know the value of XL, which is 112.25. So divided by 2 pi f. So 2 pi. Pi is equal to 3.14 into, so what is f? F is equal to 50 hertz, which is provided in the problem. So simplify this equation, 0.3573 Henry, or we can also express in terms of millihenry. So this is how we can solve the values of resistance and inductance of the circuit. Thank you.